In this lecture, I'll be talking about domain of exponential functions. The first one, if you see f of x is 1 minus e to the x, you understand that e to the x has no problem on entire real line. So then you can say that the domain of the first one is negative infinity to positive infinity. It's straightforward. If you look at the next example, you have a square root. So we know that the argument inside the square root must be non-negative. That means 1 minus e to the x must be greater or equal to 0. So now you need to find what happens to x. So first of all, you see 1 is greater or equals e to the x. So this is the exponential form. Now you can convert this one to logarithmic form. Like if you take natural log on both sides, you get natural log of 1 greater or equals natural log of e to the x. So natural log of 1 is 0, and e to the x, when you take natural log on this, is just x. So you see that your x must be lesser or equal to 0. So then if you look at on the line, say that your x is here, it should be lesser or equal to 0. So it goes on the left side. So then our domain will be negative infinity to 0 closed. Alright. So you can use the same concept when we go to C. You have in the denominator 1 minus e to the x. So in the domain, 1 minus e to the x must not be 0. So again, you can say that 1 should not be e to the x. If you apply the same concept we have applied in B, you will see that 0 must not be x. So then what happens on the entire line? I want to exclude 0. So then in the interval notation, you will write now negative infinity to 0, and then connect this one with the union symbol 0 to infinity. So you are done for C. Now we'll see the last one. So what happens in the last one, you can compare with B. So you have the same term. If I have a 0 here in B, nothing wrong. But in D, I am not able to take a 0 here even. So then I just say 1 minus e to the x needs to be greater than 0. So if you apply the same process solving this one, then you get 1 should be greater than e to the x, and then finally we have seen that this one telling us that 0 needs to be greater than x. If 0 greater than x, meaning is x is less than 0. So then your domain will be negative infinity to 0. Now it is open. Just see the difference between B and D. So in B, I have this one under the radical sign. I'm allowed to take 0. But when I'm going to D, that one is under the radical sign. Again, it is in the denominator. So I need to exclude 0. So we are getting almost same, only we make it parenthesis in here. Alright, so this is all about our domain. So in example 2, now we are taking 4 questions where we are looking for infinity limit. So it is very simple. You can see x approaches infinity. This number is less than 1. So when you have a number less than 1 and you raise exponent, very large number without bound, then that one is actually going to 0. You can understand that. Like if you take 1/2 times 1/2 is 1/4. Then again, if you multiply by 1/2, that will be 1/8. So it will be continuing decreasing. So that's why this limit goes to 0. When you look at here, this number is bigger than 1. So then this blows up. So the limit will be infinity. Infinity limit actually. Now this one, look at here. When you have infinity but the exponent is negative, so that means this number is 1 over. So if you say 1 over a small number, then it will be bigger. So then this one is going to infinity, and the same way then this one is going to 0. So then we can see that this limit goes to 0, this goes to 0, this one goes to infinity, and this one also goes to infinity. And try to understand the logic behind. So we are taking few more examples when x approaches either positive infinity or negative infinity. So when you look at the first one, you see the limit approaches 0. You know why? Because when x approaches infinity, e to the x is a very big number. So when you have 2 over a very big number, so this goes to 0. So that's the logic behind. Now when you look at b, now x approaches infinity, and you know e to the x, when x approaches infinity, is going to 0. So then you are getting 2 over 0 plus 4. So the second one will give you just 1/2. Just see. I hope it makes sense to you. Now let's go to number C, x approaches infinity. So when x approaches infinity, now you can see I have numerator, denominator, almost same exponent. So then in that case, we can ignore the free lower order terms like 7 and 6 we can ignore. So if you ignore, then it is 3 times 4 to the x over 4 to the x. So 4 to the x, 4 to the x will cancel out. Your limit will be just 3. Just see the steps. So we drop this 6 and this 7. So we end up with this portion only. Now 4 to the x, 4 to the x cancelled out. Your limit is 3. Now we have one more. The same concept. X approaches infinity. So you understand 5 to the negative x. Here 5 to the negative x, they are going to 0. So then remaining is 7, 5 to the 3x, and 5, 5 to the 3x. Again 5 to the 3x, 5 to the 3x will cancel out. Your answer will be 7 over 5. Let's see how we see. You can see the work here. I said x approaches infinity, so this term goes to 0, that goes to 0. Now these are gone actually. Now 5 to the 3x, 5 to the 3x, again you can cancel here. So then your answer will be 7 over 5. Now you can take a graphing calculator and check all these answers. The idea is very straightforward. Please do not overthink, okay? You just understand how the term is going to positive infinity or negative infinity. You may just look at graph of e to the x. It goes like this, e to the x graph. So when x approaches infinity, graph goes up. And when x approaches negative infinity, you see that this graph is going all the way close to 0.